Hi, everybody, and welcome to Module 9. So Module 9, we're going to look at more functions, and this time focus on financial functions. So I'm in the Unit 9 document. I'm actually on the terms and definitions page. So we're not going to go through everything in a lot of detail in this video. My focus in the videos is about the Excel steps, but I do strongly that you read through the module in this, or the text in this module, I should say. They talk through a lot of definitions, so if you're not as familiar with some of them, you definitely want to take your time there. Some things we're going to be looking at are going to be cash flow, so the direction in which the money flows. It can either be negative or positive, right? And of course, it depends on the user that we're referencing, right? If we have a negative cash flow, that means money is going out or flowing away. If we have a positive cash flow, it's flowing in, so maybe into the company or into the user. Again, it depends on the situation there. You'll see negative values for negative cash flow and positive for positive cash flow. When we talk about things like loans or investments, we talk about present versus future value. Present value is the current value of a loan or investment in present day, right? Whereas a future value is the future value of that loan or investment. So for instance, if we take out a loan, maybe I take out, I'm just gonna do a personal example, like a $10,000 loan, right? I wanna buy a car, I wanna take some college classes or something like that. The present value would be 10,000. And at the end of the loan, once I pay it off, the future value should be zero, right? That's my goal, is like, I have a loan in the beginning, but now I've paid it off. So in that case, I want my future value to be zero because I want my entire loan paid off. On the other hand, if I'm investing, I would like my money to grow, right? So my present value may be $10,000, but maybe my future value would be 15,000 or something different. So again, it will depend on the situation. In this video, we'll also talk a little bit about rates as well. So we'll talk about interest rates, and keep in mind that we have rates in reference to the entire year. And then we also talk in reference to specific periods. And our periods could be anything. They could be annually. So something that is annually done means that perhaps you make a payment only once a year. It could be semi-annually. So maybe you make your payments twice a year, so every 6 months. Quarterly means 4 times a year. So you would make payments, let's say, on a loan 4 times a year. Monthly, of course, is a very common. A lot of us do make monthly payments in our own lives for our car loans, our credit cards, our school loans, etc. And so on. So those tend to be the big ones. You'll probably see most examples, I would think, with quarterly being 4 times a year, monthly is 12 times a year, but you could have annually as once a year or semi-annually twice a year, for instance, as well. Things can also be calculated daily or even continuously when we start talking about compound interest and things, which is not exactly what we're doing here, but it's just worth noting that we really can calculate these things as frequently as we want to. It's just a matter of how the banking institution would like to do it, or how the company would like to do it, and so on. So I'm going to go back to, let's see which sheet, my loan analysis sheet. So here we're going to play around with some scenarios in which a company is going to loan. And there's different things we may want to calculate or need to calculate for that loan. So our loan amount, again, would be our, in this case, our present value, right? So let's say we're a company, we want to take out a large loan. We need it for various reasons. We're also going to think about how many years it's going to take for us to pay it off. How many payments we're making a year. So again, if it's quarterly, it's 4 times a year, or if it's monthly, we would make those payments 12 a year, etc. Our annual rate is the interest rate for the entire year. And then our rate per period is your annual rate, but divided by the number of times you make that payment a year. So we often look at both rates when we talk about loans and things like that. So let's start with an example. And really the goal of this video is just kind of play around with some of these new formulas and see how they work and see how we can use them. But again, if this is something that's really new, you want to go through that text a little bit more carefully and look at some of those terms. And if you need help, definitely reach out. So the first I'm going to do is kind of get set up here. So we're going to assume, let's say, an interest rate of 6%. So this sheet is already kind of pre-formatted where we have a lot of the formatting already in there. So if the percent's already done, I just typed in the number 6. And then let's assume that our company is going to take out a $650,000 loan. So I'm going to type in 650,000 as my business loan. And I'm going to do this as quarterly payments. So in this example, our business is going to pay this loan every quarter. So quarter would be 4 times a year. All right, let's see. We would like our future value to be 0, right? At the end of the time period, we would like to owe no more money, right? We're going to pay off our loan. That's our goal. Our company is going to try to do this within 5 years. Again, we're going to do this quarterly. So we would make 4 payments per year. Now, the NPER are the total number of payments. So we do make 4 payments per year, but we're going to do this for 5 years altogether. So how do we calculate this? Is we look at the number of payments per year, and we go ahead and we multiply that by the number of years. And even if it was 12 payments a year, it would still work the same way. Number of payments per year times however many years you're going to do this calculation. So we would have 20 payments there. Your annual rate is this 6%. So I'm just going to go ahead and use cell B4 there. And then for our rate per period, we're going to take that 6%. So I'm going to click cell G7. And I'm going to go ahead and divide it by cell E7 because we're looking at the rate per period. So a period could be any span of time. So here, because it's quarterly, our periods are quarters, right? So they would be every 3 months. If our loan was monthly payments, then our period would be for 1 month. So the period could be any particular breakdown. It depends on how many payments we're making a year. So we're going to go ahead and divide that by that 4 value. And you can see the rate per period is 1.5%. Okay, so what I'm going to do in this example here is we're going to go ahead and look at, well, how do we calculate our payment? So this PMT here stands for payment. So again, let's say we're the company or we're working through the numbers here and we see that, okay, our company is going to take out a $650,000 loan. We want to pay it in 5 years. We're going to do this quarterly. So we're going to make payments every quarter, every 3 months. The rate that we're looking at is 6%. So how do I figure out my monthly payment? So that's what we're going to do here. So the formula that we're going to use is equal and it's PMT. And if we just double click it, just the one that says just PMT, this is just your general payment for the period. You have to tell it a few pieces of information. So we do have to tell it our rate. So that's the first thing that we're going to go ahead and tell it. So our rate is going to be this 1.5%. So it's not the annual rate, it's the rate per period, comma. Then I need to tell it the total number of payments. So that is NPER. So I'm going to click the 20. I need to tell it my present value. So in this case, my present value is my loan amount, which is $650,000. Now, the other 2 options you're going to notice are in brackets. So that means that they're optional. You don't have to put them in, but you can. The next one is your future value. So in this particular case, we want our future value to be 0. Excel will default to 0 automatically. So that's why you don't have to put it in. But if you did have a future value, you could just click that cell. But again, Excel does default to 0 here. And then the last thing as well that we do have to put in here is the type. So the type defaults to 0 as well. So you don't have to enter it. And what happens is type 0 are for payments that are made at the end of each period, whereas type are payments that are made at the beginning of each period. So we default to 0, which is probably the most common. I know in my own personal life, that tends to be the most common type of loan is the payment is made at the end of the period. But if you need to have a payments made at the beginning of a period, you would put in a type of 1 instead. So I'm just going to leave it off because it defaults to 0, which is the end of the period payment automatically, which is what we're going to use here. And then I hit enter. Now, I am seeing here that I am getting a negative. So see how it's in parentheses. we are, this is a negative value, and it makes sense because you are spending the money, or your company is spending the money. So that's why the negative, or the payment is written as a negative here, because that money is coming out of your account. That cash flow is negative there. The loan amount is actually positive because that money would be going into your account at the beginning, right? So if you take out a $650,000 loan, your money, so it's going into the account, it's positive, but as you make the payments are negative. So that's what you see defaulting here, and those payments coming out. All right, so we can play around those. So, right, so maybe the company went in and said, okay, we're going to do $650,000. Maybe the company is looking at those payments and saying, ooh, I don't know if we can quite make that payment of $37,160 every quarter, right? That's a lot of money. So what we could do in this next example is play around with future value. So again, my goal here is to show you some of the different formulas that we can use for these different analyses. So another scenario, let's pretend that, okay, we're still going to take out the $650,000 loan. Okay. It's still going to be for 5 years. We're still going to do it quarterly. So my number of payments here is still going to be 5 times 4. And of course, you can copy some of these cells down as well. There's not a lot of cells, so I'm just kind of typing them in here. And then the same thing here. So same rate. Let's kind of pretend the basics are going to stay the same. Now, in this case, let's say our company only believes that they can make $30,000 every quarter in payments. So that extra, $8,000 too much. Realistically, maybe we think we can afford $30,000. So we can type in that 30,000 here. Notice if I type in 30,000, it does show positive. So I do want to go ahead and make sure that I put in a negative there to show and tell Excel that, hey, this money is leaving the account, we're making a payment. And then what I can do is I can find the future value. So what's going to happen here, if I'm not making the full $37,000 payment, I'm not going to pay off the loan, right? I'm going to have some of the loans over to still pay at the end. So what we're doing in the second example is we're trying to calculate how much of the loan is still going to be left over. So my future value is not going to be 0 now. We want to know, well, what's the future value going to be if I only make $30,000 payments with the same loan amount for the same time frame? We're not going to pay the whole thing off, so how much is left? So I'm going to go ahead and hit an equal sign here. I'm going to use FV for future value. And if I double click it again, it will kind of remind me to plug in, which is super helpful because there's a lot of different pieces here. So we do need to plug in the rate, and it's the rate per period, the total number of payments. Next, we're going to select the payment amount. So we told Excel, hey, we want to try for $30,000 every quarter. We are going to give it the present value because that is $650,000. And again, the type here, we can default it to 0 payments at the end of each period. So when I hit enter, I do see I have a red value, right? It's in parentheses, so this is a negative. And it's negative $181,746. So what this is telling me is that the company will still owe $181,746 at the end of the 5 years if we don't make that full payment, if we're only making $30,000 in those payments instead. So that of money to still owe at the end of 5 years, right? So that's maybe not quite working for us. So let's do a little bit more playing around here. So let's keep sticking with the 650,000 for now, right? So maybe our company really, really wants $650,000 because we need to do X, Y, Z with it, right? So we're really trying to get this full loan. Well, let's still stick with quarterly. So we're still going to use 4 here. We're still going to use the same percent and that same rate and rate per period. But maybe we really want to figure out, well, how long would it take us to pay off this loan if we're continuing to only make $30,000 in payments? Okay, so I would like my present value to go down to 0. but I can only make $30,000 every quarter. So how many years is it going to take me then to actually pay this off? So that's the question that I'm really looking for here is, if I stick with my month or my quarterly payment of 30,000, I still want that same loan amount. How long am I looking at now? It's going to be more than 5 years, right? Because we know it did not work before. I was not able to pay off that full loan. All right, so in cell F9, we're going to use NPER, just like it says here, to figure out how many payments we would have to make this work. So again, I'm going to go ahead and select my rate. Next, I'm going to select my payment amount. I'm going to select my present value. The future default to 0, but again, if you feel more comfortable, you can put it in. And again, the type we're sticking with is 0, which is the default anyway. So here I'm able to see that it would take me almost 27 payments to actually make this work instead of just the 20 payments. And then I can translate that into years as well. So if I go ahead and in D9, I'm going to hit equals. I'm going to hit my F9 cell that I just had here. I'm going to go ahead and divide it by E9. And I can get the answer of a little more, or about 6.5 years to pay this off. So I take my total payments here and I divide it by however many payments per year. So what I'm left with is the number of years. So if we want to stick with that 650, still only make $30,000 payments, we're looking at more like 6.5 years to pay off this loan, a little over, not just 5 years. And I don't know about you guys, but this is something that I actually do in my personal life. I don't always use Excel. Sometimes I'll just go to the online calculators and save myself some work there. But I do play around with stuff like this. If I'm buying a new car and I think about, okay, what could be my potential interest rate? What is that monthly payment going to look like? What if my loan is only 15,000, not 20,000, right? What if I get a cheaper car? And I really do play around with all of this, just like we're doing here, to kind of get an idea of what to expect. What do I really think I can afford? What seems reasonable, right? You may think like, oh, I can afford that car. And then when you see the monthly payment, you realize, oh, that's a lot more than I expected, right? So it is a good idea, or it's not a bad idea to, kind of think about some different scenarios that are happening and what is reasonable for you personally or for your company, right? If they can't do 5 years, then either you need to take out a smaller loan or you need to increase however many payments that you're making. So there's things that you have to consider if that monthly or quarterly payment is to work. All right, the last one I want to do here in this video is look at present value. So thinking more about the loan amount. So in the other examples, we kind of were playing around in this last example, thinking about, okay, let's keep the same loan amount, but how many years would it take me to pay it off at a payment plan that I can manage, right? And it was 6.5 years. And maybe this is too long. You're like, no, that's too long. I can't really, 6.5 years, my company's not going to go for that. We want to keep it under 6 years or 6 or under or something. So maybe you have to consider a new loan amount. The 650,000, although that's what you want, may not be what's going to happen in this case, right? So that's what we're going to focus on. This last example is how to calculate the loan amount and kind of go backwards. All right, so let's see what we're going to do. We're going to copy down some of the information here. So again, we would like our final value to be 0 to pay off this loan. Let's stick with 5 years again. Let's stick with quarterly payments. So again, we're just looking at 20 here. We're going to stick with the same annual rate. All right. Let's say in this case, our company kind of reconsidered, said, okay, we think we can do $32,000 each payment, not just 30. So we'll up it a little bit. If we cut back on some other places, maybe we can do a little bit more. We can make 32,000 work. So let's try 32,000 this time. And we're going to work backwards here and kind of say, well, what would our loan amount be then? What can we afford working backwards? So I'm going to go to my loan amount cell here. And I'm going to use the formula PV for present value. And again, I'm going to hit my total number of payments. my payment amount, which is going to be $32,000 every quarter. And again, our future value here is going to be 0. And when I do that, I get about $550,000. So in this scenario, maybe this is more reasonable for our company. We feel pretty confident that we can make that $32,000 payment every quarter. That $38,000 is just too much. So that's going to be too much for us. We're going to go with a loan instead of $550,000.